So, welcome class 12, right? So I'm Vivek, and today we are going to do a third class of this chapter, that is alcohol, phenol, and ether. So before starting the class, let me check the technical terms. Like my screen is all visible to all of you. Okay, and my audio is also audible. My voice is also audible to all of you. Okay. Okay. So if you have any problem related to the voice or the screen you weren't able to see, then you can just text me so that we can. Yeah, right. So in today class, basically what we are going to do in previous two class, we are revising, that is alcohol, phenol, and ether chapter. So we do complete revision of this chapter. Also did some question related to this chapter, right? So basically in today class, that is, this is the third class of this chapter, right? Okay, good, right. Hmm. So this is the third class of this chapter, that is alcohol, phenol, and ether. So before starting of this class, let me discuss the learning objective of this class. So what we are going to learn by the end of this class, right? So basically, we are going to learn in this class, that is the electrophilic substitution reaction, right? So our main focus for the today class is, that is how we understand the electrophilic substitution reaction in case of phenol, because alcohol parts and the method of preparation of phenol, we already discussed all this thing, right? So in today class, basically what we are going to do now, we are going to do the quick revision of this electrophilic substitution reaction, and try to solve some question related to this electrophilic substitution, right? So at the end of the lesson, students are able to solve the problem, right, related to the electrophilic substitution reactions and all. So these all are the learning objective of today class, right? Okay. Now, before starting the class, let me quickly recall our previous class. So in our previous class, we are talking about the acidic properties of phenol, right? So we know that whenever the electron withdrawing group, right, whenever the EWG, that is electron withdrawing group, that is EWNG, this is known as electron withdrawing group. Electron withdrawing group such as halogen, or we say NO2. So whenever the electron withdrawing group such as halogen Na2 are attached to the phenol, they increase the acidity. Right. Similarly, in case of cyclohexanol also, whenever we introduce some electron withdrawing group, they always increase the acidic character, because acidic character is directly proportional to the I effect. Right. So this is very important point. That is acidic character. Right. That is acidic character is directly proportional to minus I effect, directly proportional to minus I effect, right? So this is the acidic character, which is directly proportional to minus I effect, and also plus inversely proportional to the plus I effect. And we know that minus I effect depends upon what? That is the nature of electron withdrawing group. So whenever electron withdrawing group is attached to the either in case of cyclohexanol or phenol, they always introduce minus I effect, and due to this only their acidic character increase, right? So this is all we did in the last class. This all thing ये सब हम लोगों ने already last class में cover कर लिया था. Okay, so इस question का answer दो. This is a very very simple question that's come in the JEE in 2023 13th April exam, right? So what the question basically? So this is the assertion and reason type of question. So they are asking, what is the order of acidic nature of the following compound? That is A, B, and C, right? So out of this, that is we have a A, B, and C. So in A we have a chloro group, in B we have a fluoro group, and C we have a CH3 group. So we all know that CH3 group is a electron donating group. Yeah. So you all try to solve this question. Yes, JNP Ahmednagar just joined, right? Okay. So just try to solve this question. That is, what is the correct order, right? Order of the acidic nature of the compound, that is A, B, and C. So assertion is given, that is the order of the acidic nature of compound is A is greater than B is greater than C. So is this the correct order? Can anyone? Is this the correct order? A, B, C. And what is the reason given? Reason is fluoro is the strong electron withdrawing group than the chloro group. So this is very much true, right? Because we know that out of fluorine, chlorine, bromine, iodine, we know that fluorine is more electronegative as compared to chlorine, bromine, and iodine. So more the electronegative value, more in the EWG group, that is electron withdrawing group. So reason is absolutely correct, that is the fluorine is a stronger electron withdrawing group. But why the order of acidic is like A, B, and C? Can anyone? JNB Ahmedabad, JNB Ahmednagar. Anyone wants to say anything about this? Yeah, JNB Rajkot also joined. Yes, guys, please join quickly so that we cover all these things. Yeah, good. Yes, JNB Ahmedabad, JNB Ahmednagar, JNB Rajkot. Yeah, they all joining. Okay, so this is the recall test question. Basically, from the last class, we already talked about the acidic character, right? So, can anyone explain me out of this assertion and reason what is correct? The assertion is correct. Reason is correct. Does the reason is the correct explanation for the assertion or not? Right. So the order of the acidic nature of the compound is A is greater than B is greater than C. Is it true? Anyone? कोई भी कुछ बताना चाहता है? JNV अहमदाबाद राजकोट. Anyone? This order is correct or not? तुम लोग चैट बॉक्स में लिख सकते हो, राइट? या तुम लोग चैट बॉक्स में लिख सकते हो, कोई भी किसी को कोई भी यहाँ पे डाउट हो, कुछ भी पूछना हो, राइट? So we know that acidic character is directly proportional to minus I effect. Okay. So those who join later, yes, some reply. Good afternoon, sir. JNB Bhavnagar also joined. Right. Good. So yes, can anyone tell me the correct order for the acidity for the following given compounds? Out of ABC, does the order is given order is correct or not? Yeah, assertion is wrong. Okay, and the reason is correct according to JNV Changan. Okay. Anyone? JNV Ahmednagar, Ahmedabad, Rajkot. Anyone wants to say anything related to this? I got only one, one answer for this question. Only one reply from all of you, right? Okay, so let me come to the point. Beta, if I'm talking about the assertion, right? So the acidic order, we already told you, I already discussed this thing in last class also. If you're talking about the acidic nature, it behave on the minus I effect, right? So on this basis, minus I effect, this is very much true. That is B is more acidic than C than A, and after C is the least acidic because they contain electron donating group like CH3. But here one factor is also very very important, जो तुम लोग neglect कर रहे हो, जो तुम लोग नहीं ले रहे हो. And what the factor is? The factor is I effect also depends upon the distance. Right? Here we can observe that the distance is very less. This chlorine is attached to the ortho position only. Right? Where this fluorine is present at the para position. So I effect also depends upon the distance. So as we increase the distance, right? As we increase the distance, this effect minus I effect start decreasing. राइट जैसे जैसे डिस्टेंस को इंक्रीज करोगे माइनस आई इफेक्ट अपने आप क्या होने लगेगा कम होने लगेगा एंड द रिजल्ट ऑफ दिस इज द ओनली रीजन व्हाई ए इज मोर एसिडिक देन बी गॉट इट सबको समझ आया होना था बी ज्यादा एसिडिक बट व्हाई ए इज मोर एसिडिक दिस इज जस्ट बिकॉज ऑफ द फैक्ट I effect also depend upon the distance and in case of B that is a fluorocyclohexanol. Right. In this case, the distance is far away as compared to. That's why this problem is takes place. Right? Understand? Yes. Got it? Chalo. Very good. Now, the reason is also correct now. Fluorine is a stronger electron withdrawing group. So, what is the correct answer for this question? Can anyone? Yeah. Repeat, sir. Okay. JNB Ahmedabad. Repeat. Okay, beta. दोबारा बताता हूँ तुम लोगों को. I'm just asking about the acidic order of this following compound. Right. So we know that acidic character depends upon I effect. Yeah, this I effect, that is plus I effect and minus I effect. Minus I effect is totally due to presence of electron withdrawing group such as chlorine, fluorine, bromine, iodine, or we say nitro group, right? If I'm talking about plus I effect, so plus I effect is due to presence of electron donating group like CH3 group, right? This thing is clear. Okay, so acidic character depends only upon the minus I effect. So on the basis of this, you can say that yes, B is much more acidic. That is, fluorine is much more electronegative. So they will produce more minus I effect. But one important note here, this inductive effect or we say minus I effect also distance dependent effect. मतलब ये distance पे भी depend करता है. Here we can say that यहाँ कार्बन और क्लोरीन के बीच का डिस्टेंस कम है. Now here the distance between this carbon and this fluorine is very much because this fluorine present in the para position, right? So if the distance is more, then this effect become weak. This effect is weakens. मतलब जैसे जैसे डिस्टेंस बढ़ेगा माइनस आई इफेक्ट कम होता जाता है. तो इसीलिए फ्लोरीन होना चाहिए था एक्सपेक्टेड फ्लोरीन टू बी हाईएस्ट एसिडिक बिहेवियर, बट ड्यू टू दिस डिस्टेंस issue, chlorine, that is a orthochloro or we say 2-chlorocyclohexanol is good acidic behavior as compared to fluorocyclohexane. ये क्लियर है दोनों को. And why C is the least? Because C consists of electron donating group, and we know that whenever the electron donating group is attached to the group, they always decrease the acidity, right? So the correct answer is which one? Yeah, that is B. Both A and R are true, but R is not the correct explanation of it. Always remember this. Both A and R, assertion and reason, both are true, but reason is not the correct explanation. What is the correct explanation? Correct explanation is inductive effect minus I effect, which decrease as the distance increases, right? So both assertion reason are true, but reason is not the correct explanation of the assertion. आप सबको समझ आ गया? जल्दी फटाफट बताओ. चलो, वेरी गुड, गुड. So I got couple of yeah, very good, very good. सबके रिस्पॉन्सेज आ रहे हैं. That's it seems to be कि सबको क्लियर हो गया, राइट? चलो, बहुत बढ़िया, वेरी गुड. चलो, नाउ लेट्स मूव टू द टुडे टॉपिक, राइट? तो ये हम लोग का रिकॉल था एक तरह का, जिससे हम लोगों ने अपनी लास्ट क्लास को अच्छे से रिकॉल कर लिया. So this is the today main agenda, right? This is the today topic that what we are going to do. This is a very, very, very important. Why very important, beta? Because in any organic chapter, whether I'm talking about alkyl halide aryl, whether I'm talking about phenol, whether I'm talking about the aldehyde or ketone, carboxylic acid, or last but not the least, aniline, or we say amine chapter. So in all these chapters, this electrophilic substitution reaction play a very crucial role. So you must know before, before predicting the product of any of the reactant, you must know the mechanism behind this. That what is this electrophilic substitution reaction basically, right? So what is this electrophilic substitution? So as we can see that this electrophilic substitution reaction, the name suggests that electrophilic and substitution. So what do you mean by electrophile? Can anyone tell me? Yes, JNB Ahmednagar, Rajkot, JNB Changal, and yeah, anyone want to say anything related to this? What do you mean by the terms electrophilic? Anyone? You all know now this thing, electrophilic, nucleophile, right? Yeah. JNB Nanded, JNB Kolhapur, huh? Anyone? What is this? Electrophilic. Yes, very good. That is electrophilic means, got it, right? Electron loving species, JNB Ahmedabad. तो JNB Ahmedabad हमेशा रिप्लाई कर रहे हैं, क्लैप फॉर, राइट? एंड बाकी रेस्ट जितने भी बच्चे हो बेटा, तुम लोग भी पार्टिसिपेट करो, राइट? बेटर इंगेज रहो, दोनों का इंटरेक्शन होना चाहिए. जो भी डाउट आता है, जो गलत बोल रहे हो, सही बोल रहे हो, कोई बात नहीं, एक बार अपने बिहेवियर, अपने आंसर्स को बताओ, ठीक है? दैट्स वेरी बेनिफिशियल, राइट? गुड. Now, electrophilic means, according to JNB Ahmedabad, they are saying electrophiles means electron loving. Yeah, very much correct, right? So those compound having, electron loving character, right? Electron loving species are known as electrophiles. It means electrophile itself electron deficient compound, right? उनके पास electron नहीं होता. And due to electron deficient nature, they also known as Lewis acid. So we can call as electrophile as a Lewis acid also, electron deficient also, because they have a deficiency of electron and they want to react with those having more number of electron, right? So electrophiles हमेशा उनके पास जाना पसंद करेंगे जहां पे इलेक्ट्रॉन ज्यादा हो. समझे? ज्यादा हो से क्या होगा? उनके पास जाके इलेक्ट्रॉन को वो ले सकते हैं, right? So basically electrophiles are also called Lewis acid. They also known as electron deficient compound. That's why they having positive charge. Right. So whenever we talk about the electrophilic, they're always having positive charge. They show that they're having deficiency of electron. Right. Now, basically, the hydroxyl group is a powerful activating group, and hence phenol readily undergo electrophilic substitution reaction. Why this is? Dekho. We know that if we draw the structure of phenol, I guess we all know that how we'll draw the structure of phenol, because we all discussed this thing in the previous class. So this is the structure of phenol, right? So we know that in this structure, oxygen having lone pair of electron. So this lone pair of electron through resonance, they can contribute to this ring. And this ring become powerful activating group. So when we know which ring is activating ring and which ring is deactivating ring, so whenever some electron donating group is attached to the ring, like hydroxy group, like amine group, right? Like ether group. So whenever these kind of group is attached to the benzene ring, right? They always tendency to donate electron and make the ring more activating. On the other hand side, when the group like electron withdrawing group, like chlorine, fluorine, NO2, so they always want to take the electron away from the ring. So the ring become deactivate, right? So always remember this thing, beta, when you have to say activating and when you have to say deactivating group. So whenever electron donating group is attached, that is EDG. So whenever electron donating group is attached to this, then it is known as activating group. On the other hand side, whenever the electron withdrawing group attached to the this benzene ring, they make this ring deactivating, right? So in this reaction, an electrophile, that is electron loving species, attack the benzene ring and replace one of its hydrogen atom, right? And from which position they are going to remove? We are going to discuss this thing also, right? Since the ortho and para position of phenol are electron rich, can anyone tell me how we can say that the ortho and para position of the phenol are electron rich? Anyone? Right. So the substitution takes place at this position only. And two such reaction, that is halogenation and nitration, we are going to discuss, right? So let us discuss this thing, how halogenation nitration will take place. So before this, I'm going to explain why only ortho and para position are called electron rich. Yeah, I got one. Resonance effect. Okay, someone says resonance effect. Very good. Good, beta. Okay, so let me explain this thing in a detail so that everyone get to know what do you mean by this ortho and para position, why phenol are electron rich at this position, right? Okay, so basically this is the structure of phenol, right? So this is the structure of phenol. So if I draw the structure of phenol, this is the structure, right? And we know that oxygen having lone pair of electron. So due to resonance, whenever this lone pair of electron is donated, the electron density is increased only at ortho and para position. So we can say that only at ortho and para position, we get the more electron density, right? We get the more electron density. Like in first case, we have 2 electron at this position, right? So we have a 2 electron at this position. This remains same, this remains same. So in the next, we have a 2 electron here. In next, we have a 2 electron here. So we can observe that electron density means what? That is number of electron per unit volume, right? That is the electron density is more at only ortho and para position, right? I guess we all know that now which position is called ortho, para and meta. So this position is called ortho, right? This position is called meta position, and this position is called beta para position. So in phenol, whenever electron donating group is attached to the benzene ring, इलेक्ट्रॉन डेंसिटी इज मोर एट ऑर्थो एंड पैरा पोजीशन. अब खुद सोचो यार, इलेक्ट्रोफाइल कहाँ आएगा? इलेक्ट्रोफाइल को तो इलेक्ट्रॉन चाहिए, तो वो तो वहीं आएगा ना जहां पे इलेक्ट्रॉन डेंसिटी बहुत ज्यादा हो, राइट? सो the ortho and para position have a maximum electron density. So that's why electrophile come and attack to these two position only. That is ortho and para, not at the meta. Because in meta, compared to ortho and para, less electron density. Right. So always remember this thing. Whenever electron donating group is attached to the benzene ring, reaction takes place only at ortho and para position. And if someone asks why only ortho and para position, then you have to say because electron density ज्यादा होती है ortho और para पे as compared to the meta. चलो. सिमिलरली इलेक्ट्रॉन विड्रॉइंग के लिए क्या होगा, तुम लोग सोच के रखो, क्योंकि नेक्स्ट क्लास में हम लोग यही करने वाले हैं. जब एल्डिहाइड लग जाएगा, कीटोन लगेगा, कार्बोक्सिलिक, तो बताना रिएक्शन कहाँ होगा, ऑर्थो, पैरा या मेटा पे. तो दिस इज अ होमवर्क क्वेश्चन फॉर यू ऑल, राइट? इसको प्रिपेयर करके रखना है कल के लिए. चलो, सो लेट्स सी द फर्स्ट इलेक्ट्रोफिलिक रिएक्शन, that is halogenation, right? So what do you mean by this term halogenation basically? So halogenation means nothing but when reaction of the phenol with halogen in presence of two things that we are going to consider here. One, in presence of aqueous or we say water, and another thing is CH2, carbon disulfide, right? So in both things we get the different product. And why we get the different product? This is the main question here, right? So let's first think what happened when the halogenation of phenol will takes place, right? So this is phenol. We all know that whenever the halogenation of phenol is takes place in presence of water, always 2,4,6 tribromophenol will be formed. What is the name of this compound? That is 1, 2, 3, 4, 5, and 6. So this is known as 2, 4, and 6. We have a bromine group 2, 4, 6. That is tribromophenol. So this is what we get. That is 2, 4, 6 tribromophenol plus 3HBr. So always remember this thing, beta. That is the halogenation of phenol in presence of aqueous or we say water gives us 2, 4, 6 tribromophenol. Now someone says, why this takes place? What is the reason behind it? Sir, अभी तो आपने बोला था कि ऑर्थो और पैरा बनता है. Then why this will take place? Okay, someone says, sir, please zoom the screen. Okay, beta. Right? अब visible होगा सबको, ठीक है? So why this takes place? Why this is happening in case of aqueous? Why 2,4,6 tribromophenol is formed? Why? So a very interesting reason here, beta. In case of aqueous water or we say water, the benzene ring or we say the phenol ring get activated, right? They will get activated. This ring get activated more. And the substitution takes place at all ortho-para position. Basically, at room temperature and in aqueous, that is presence of H2O, that is water, the electron density increase at all ortho and para position. This ortho position, this is para, this is also ortho para position, right? Therefore, electrophiles, when the electrophiles come, that is Br plus, they will substitute at all ortho and para position, right? Similarly, if the halogenation of phenol takes place in presence of CH2, that is carbon disulfide, then only ortho and para bromophenol will be formed. Ortho bromophenol is formed in a very less amount, or we say minor, so we can neglect it this. Right, 2-bromophenol is present in a very less quantity, or we say minor product. So the major product here is 4-bromophenol. So always remember, जब phenol को treat करेंगे हम लोग H2O के साथ, always 2,4,6,5-bromophenol. और जब हम उसको treat करेंगे Br2 in presence of CH2, that is carbon disulfide. So always remember रखो क्या बनेगा, ortho and para, not like 2,4,6. ठीक है? So this is all about the halogenation. Now, what happen in case of nitration, right? So what happen in case of nitration? So basically in nitration also, phenol gives a mixture of 2-nitro and 4-nitrophenol, like ortho and para, we can say that 2-nitro and 4-nitrophenols on nitration with the dilute nitric acid. So here we can say that this is only a 20% HNO3. You know what do you mean by this 20% of HNO3 only? 20% of HNO3 means what, beta? Yes, anyone? Only 20% of HNO3 means this is very, very dilute. Out of 100 ml of HNO3, we use 100 ml of the solution, only 20 ml of HNO3 are present, rest is water. That is 80 ml is water only. So we take HNO3 as a dilute quantity here. So whenever the phenol is react with the dilute HNO3 at 298 Kelvin, what will form? Ortho-nitrophenol and para-nitrophenol, because we know that electron density is more only at ortho and para position, right? Now, here, one important factor is which one is major and which one is minor in this case, right? So while CS2 tri-substitution doesn't take place. Yes, beta. Basically, beta, why in case of aqueous, or we say H2O, right? Ring is highly activated, right? Highly activated means what? That is electron density is very much at all ortho and para position. But in case of CH2, since at low temperature and CH2 is less polar, right? Here I'm write the reason also. CH3 using the low temperature and less polar solvent such as carbon disulfide. So carbon disulfide is a very, very less polar as compared to water. And due to this only, this ring is not highly activated as compared to aqueous, right? So in above case, that is with the water, in aqueous, water being more polar, so they activate the ring, or the ring become highly activated. And this thing won't happen in case of CH2 in presence of carbon disulfide, right? Ring is not activated as much, right? इसीलिए वहां पे ऐसा नहीं हुआ. Now, the next is, yeah, got it? Very good. Now, the mixture of nitrophenol so obtained is separated using the steam distillation, right? So हम लोग को दो प्रोडक्ट मिल गया. सबको क्लियर ये चीज? दो प्रोडक्ट मिला, that is ortho and para. Why ortho and para only, beta? Because this is electron donating group, and we know that whenever the electron donating group like phenol, the substitution takes place only at ortho and para position. Right. So this ortho nitrophenol is 30 to 40% and this para nitrophenol is 15%. So the mixture of nitrophenol so obtained is separated using the steam distillation. So always remember this thing, beta, कि जब भी नाइट्रो ऑर्थो नाइट्रोफिनॉल एंड पैरा नाइट्रोफिनॉल मिलता है तो उससे को कैसे सेपरेट करेंगे? So हम लोग कैसे सेपरेट करेंगे? With the use of steam distillation. Now both these products show hydrogen bonding. ठीक है, दोनों प्रोडक्ट हाइड्रोजन बॉन्डिंग को शो करते हैं. In case of 2-nitrophenol here, ortho, it will show intramolecular. So what do you mean by the intramolecular or intermolecular hydrogen bonding? Can anyone explain me? JNV Rajkot? Can anyone? JNV Panchmahal? Can anyone? What do you mean by this term intramolecular and intermolecular hydrogen bonding? Chalo, very good. So in case of 2-nitrophenol, the hydrogen bonding is intramolecular. Intramolecular means in the same molecule. जब आपस में ही हो जाता है, आपस में ही hydrogen bonding हो जा रही है. That is called intramolecular. Within the molecule, right? Intramolecular. GNV Nanded. Very good, beta. right? So the hydrogen bonding is intramolecular in the same molecule. Whereas in case of the 4-nitrophenol, it is intermolecular, that is between the different molecule, right? So इसको देखें एक बार कैसे दिखता है, क्योंकि देखोगे तो और अच्छे से क्लियर हो जाएगा कि ये सर क्या बोल रहे हैं, व्हाट डू यू मीन बाय द इंट्रा एंड इंटर, आपस में कैसे होता है, तो डिफरेंट मॉलिक्यूल्स के बीच कैसे होता है। तो चलो इसको देख लेते हैं एक बार फटाफट। या so this is the inter and intramolecular hydrogen bonding as we see in this between ONH। देखो हाइड्रोजन बॉन्डिंग से 3 लोगों के साथ बनता है, किसके साथ, याद करने का तरीका, फोन, ऑलवेज रिमेंबर फोन, फोन, फोन मीन्स फ्लोरीन, ऑक्सीजन, नाइट्रोजन। सो ओनली ये 3 ही लोग हैं जिनके साथ हाइड्रोजन हाइड्रोजन बॉन्डिंग बनती है। ये नहीं कि तुम HCl देख लो तो बोलो कि हाइड्रोजन बॉन्डिंग है, वो हाइड्रोजन बॉन्डिंग नहीं है। PH3 देख लो बोलो हाइड्रोजन, नो दिस इज नॉट द हाइड्रोजन बॉन्डिंग। हाइड्रोजन बॉन्ड इज फॉर्म ओनली विद द 3 एलिमेंट, दैट इज फ्लोरीन, oxygen and nitrogen, because only these 3 elements having maximum electronegatividity value as compared to hydrogen, right? So only these 3 elements, that is FON, will make hydrogen bonding। कभी भी ये मत समझना HCl PH3 ये भी hydrogen bonding है, okay? चलो तो यहाँ पे तो O और H है, obviously hydrogen bonding will be formed here। In case of 4-nitrophenol we have a OH, right? So this will form hydrogen bonding with the another molecule of the same nitrophenol, right? Here we can see that intramolecular hydrogen bonding between the another nitrophenol molecule. So whenever the two different molecules are taken, right, we say we got intermolecular hydrogen bonding, and within the same molecule we say this is a इंट्रामोलिकुलर, राइट? तो ऑलवेज रिमेंबर इंट्रा एंड इंटर। इंट्रा मींस आपस में ही और इंटर मींस दूसरों के साथ। जल्दी से बता दो मेरे को, ये क्लियर है क्या? फिर आगे बढ़ते हैं। ये सभी लोग जल्दी बताओ, इज दिस क्लियर टू एवरीवन और एनीवन हैविंग एनी काइंड ऑफ डाउट टिल यू कैन आस्क। यस सर, क्लियर है, वेरी गुड, चलो गुड। Now, let's move to the next question. That is Colby reaction, right? This is also a very, very, very important reaction, right? So, what is this Colby reaction? Yes. Someone text me. Yes, samajh aa gaya sab. Good. So, Colby reaction. So, basically, it involves the sodium phenoxide, which is allowed to absorb carbon dioxide and then heated under a pressure of CO2 to 398 Kelvin. So, what is happening in this reaction, beta? Anyone? That is, it involves sodium phenoxide which is allowed to absorb carbon dioxide. So सबसे पहले sodium phenoxide बनाएंगे and they are allowed to absorb this carbon dioxide and then heated at a high pressure to produce the salicylic acid, right? This is salicylic acid. So I hope this is clear, everyone. Chalo. So sodium salicylate, so obtained on acidification, gives the salicylic acid. So let's see the reaction of the Colby reaction. बहुत इंपॉर्टेंट रिएक्शन है। अब इसका मैं एक यूज बताऊंगा जो हम लोग मेडिकल पर्पस पे करते हैं, राइट? सो दैट यू कैन नो just imagine this thing that how important this salicylic acid is, right? So this is the reaction here when we treat phenol with the NaOH, that is whenever we treat phenol with the sodium hydroxide, it will form sodium phenoxide, right? We see this thing, ONA will be formed, right? And this H2O will be removed. So sodium phenoxide will be formed. Now, when this phenoxide is treated with CH2 under the pressure of 4 to 7 atm and the temperature of around 300 Kelvin, they will form sodium salicylate, right? So sodium salicylate will be formed, that is OH and CONA, which on the acidic hydrolysis, that is in presence of H3O plus, it will give salicylic acid. So this is all about the Colby reaction. Always remember, in Colby reaction, we produce salicylic acid from phenol. So this is the very, very important method. Now, by the reaction with acetic anhydride, salicylic acid gives aspirin, which is the common pain reliever, right? So we all heard about the aspirin tablet, right? So this aspirin tablet is a very good pain reliever medicine. So how will you obtain? How will you obtain beta? So whenever we treat salicylic acid with the anhydride, right? So when we treat with the anhydride, let me, write this reaction also so that you came to know what happened. So this is basically the structure of salicylic acid, right? So this is the structure of salicylic acid, right? This is the salicylic acid. And what happened when by the reaction of acetic anhydride with salicylic acid, right? So acetic anhydride. So what is this acetic anhydride? Can anyone tell me? What is this acetic anhydride? That is CH3, right? This is C double bond O, right? This is nothing but O. Again, we have CH3, C double bond O, and this. So this is the acetic anhydride. So how aspirin will be formed? What is the structure of aspirin? So when we treat salicylic acid with anhydride, what we get beta? क्या मिलेगा हम लोगों को? So हम लोगों को मिलेगा that is nothing but COH and this is OC, right? And this is OCH3 and byproduct क्या मिला है भाई इसके साथ साथ? Very important, that is CH3COH, right? So this is known as aspirin. Always remember. So this is known as aspirin. So this is how we can, prepare aspirin from the salicylic acid. सबको समझ आया aspirin कैसे बना? जल्दी बता दो एक बार, फटाफट. All of you. I'm waiting for you reply. All of you, please confirm me. सबको समझ आ गया how aspirin will be formed by the salicylic acid? Sir, please repeat. Mandate. Okay. Beta, basically in Colby's reaction, what we'll prepare, right? Yes, sure. Okay. So in case of the Colby reaction, we prepare salicylic acid, right? This is the salicylic acid. Now, when we treat salicylic acid with the anhydride, what is this anhydride? This is the structure of anhydride, right? That is CH3C11O, CH3C11O, and this O is this is common in between these two, right? So this is the anhydride. So when we treat salicylic acid with the anhydride, we get aspirin plus CH3COH, right? So always remember this thing. कई बार ये पेपर में आया है. What happened when the salicylic acid is treated with the anhydride? Then you must remember whenever the salicylic acid is treated with anhydride, we got what we formed? We formed aspirin. Sure. Clear as a book? Right. Now, the next reaction is oxidation. So this is also a very important reaction. That is phenol undergo oxidation reaction to give the product which are different from those obtained by the alcohol. So always remember this. Acha, can anyone tell me what happened on oxidation of alcohol? What product we get? हम लोगों को कौन सा प्रोडक्ट मिलता है या कौन सा प्रोडक्ट मिलता था जब हम लोग ट्रीट करते थे अल्कोहल का ऑक्सीडेशन कराते थे विद K2Cr2O7 और we say KMnO4? Anyone? ऑक्सीडेशन ऑफ अल्कोहल हमने ऑलरेडी किया. या आई गॉट वन. दैट इज कार्बोक्सिलिक एसिड. गांधीनगर, JNV गांधीनगर इज कार्बोक्सिलिक एसिड, right? We can also say that we get aldehyde as well. Aldehyde भी मिलता था. Good. So we get aldehyde and ketone as well as the carboxylic acid, right? So if we do the controlled oxidation, then we'll get aldehyde and ketone. If the uncontrolled oxidation takes place, then we get carboxylic acid, right? So phenol undergo oxidation reaction to give the product which are different from those obtained by alcohol, right? And they can be oxidized using a variety of oxidizing agent, right? So they can be oxidized using a variety of oxidizing agent such as sodium dichromate or silver oxide to give phenol. So this one is very important. Always remember this thing, right? Whenever the oxidation of phenol takes place, this gives us phenol, right? Like benzaquinol. So this is the phenol, and we treat phenol with the, we also known as the sodium dichromate or known as the Fermi salt. Then what we'll get, beta? We'll get the benzaquinol, right? So this is what we got. That is benzaquinol. Clear है सबको? right? Very good. What is this quinone, right? So quinone means beta having two different two ketonic group, right? So they contain two ketone group. That is, this is double bond O. This is also double bond O. So this is known as a benzoquinone, right? So this is a compound having ketone as a functional group, known as benzoquinone. Clear है सबको? What is quinone? Right? Sure. Now, this is also very, very, very good reaction, beta, right? That is RTM. So this is one of the most important reaction of this chapter, phenol, right? So ये बहुत ज़्यादा important reaction है, whether you're talking about your JEE, NEET, or even your CBSE examination point of view, this RTM reaction is very, very important. Generally, they are written as RTM, right? Generally, they are written as R, T, and M. So this is the RTM. So basically phenol react with the chloroform in presence of sodium hydroxide or potassium hydroxide solution followed by acidification to give hydroxyaldehyde, right? So how this reaction takes place? Let's discuss this thing, right? So here we have a phenol. When we treat phenol with the NaOH, we get sodium phenoxide, which further on treatment with CO2 give ONA, that is phenoxide, and CHO group is introduced. On further hydrolysis, this will give salicylic. So in Colby reaction, we got salicylic acid because instead of CHO, we have a COOH, carboxylic group is present. But in this case, we get CHO, that is known as salicylic. Now, use of carbon tetrachloride in place of chloroform, right? So in place of chloroform, if we are using, right? So in case of chloroform, if we are using what? If we are using in place of here, we have a chloroform, right? CHCl3. So in place of CHCl3, if we are using CCl4, that is carbon tetrachloride, then we get salicylic acid, right? Always remember this thing. If we have a CHCl3, we'll get salicylic, and in this case we have get salicylic acid. Okay, this is nothing but salicylic acid. Always remember this thing. Okay. So अगर आप CCl4 यूज करोगे तो आपको मिलेगा salicylic acid COOH group, and if you are using chloroform, that is CHCl3, then you get salicylic. ठीक है? So this is all about the RTM reaction. Now last reaction, and this is also a very important reaction, that is the esterification. So similar to alcohol, phenol react with carboxylic acid to give the ester. Right. So just like in alcohol, we know that the hydrolysis of alcohol, if we do the hydrolysis of alcohol, we'll get this thing. Right. This reaction is reversible in nature as well. So similar to alcohol, phenol react with carboxylic acid to give the ester. So here we have, 2-hydroxybenzoic acid, also known as a salicylic acid. And when this react with the ethanoic acid, this reaction is reversible in presence of some acid. What you will get? You will get acetyl salicylic acid, right? So this reaction is an acylation reaction, as of H on OH of the phenol is replaced by the acetyl group, right? So this is known as a esterification. Remember this thing. Now, also one more important reaction of this chapter is coupling reaction. So what is this coupling reaction actually? So basically phenol react with the aromatic diazonium salt in a slightly alkaline condition to give this azo compound. So as the name suggests, na, coupling reaction. Coupling reaction means whenever the BDCs react with the phenol, they will form an orange solid, also known as a para-hydroxyazobenzene or paraphenyl azophenol, right? So let's see this reaction. These azo compounds are brightly colored and are used as the azo dyes. Always remember this thing. These are compounds are brightly colored and they are used as azo dye. So this is how we all know BDC. BDC. In this BDC, you also talked this about BDC in the alkyl halide chapter. In case of Gutterman and Stephen reaction, वहाँ भी हम लोगों ने BDC को समझा था. So whenever the BDC is react with the phenol, what happened, beta? We all know that all this having one H, right? They all having one H. So this HCl will be removed, right? This HCl will be removed. and N double bond N will be formed. So this is known as azo, right? So this is the carbon double bond carbon is known as azo. So para hydroxy azobenzene will be formed. So this is known as the coupling reaction, and the final product we get is known as para hydroxy azobenzene, right? So this is all about the केमिकल प्रॉपर्टीज ऑफ फिनॉल. ठीक है, तो हम लोगों ने पूरा अल्कोहल और फिनॉल पूरा कवर कर लिया हम लोगों ने अब. सो जल्दी से क्विकली समराइज करते हैं, माइंड मैप्स करते हैं, and then we are going to solve some one two question related to this, and I'm also going to give you a homework, right? So mind maps फटाफट देखते हैं इस चैप्टर के माइंड मैप्स क्या क्या है. So सबसे पहले what we discussed, that is alcohol, right? So let's see the mind map for this alcohol chapter. This mind map help you a lot to remember all this thing in the memory way. So this is the physical property. If I'm talking about the physical properties of alcohol, so you already discussed three things only in the physical properties, that is melting point, boiling point, and the solubility. So if I'm talking about the melting and boiling point, more than alkanes, so they show good amount of melting and boiling point if I'm comparing with the alkane. Similarly, solubility of the alcohol is also very good. Why? Due to presence of hydrogen bonding. Right. So due to presence of this hydrogen bonding, solubility is also very much high. Now, if I'm talking about the chemical properties, in chemical property, we cover breaking of H bond, breaking of OH bond, and breaking of CO bond. So in breaking of OH bond, we react with the metals, esterification, dehydration. Similarly, in the breaking of CO bond, we study about the oxidation and the reaction with the HCl, right? HCl, or we say HBr, all this thing. Use. So we use as a solvent, high alcohol used as a very good solvent, and the preparation of other organic compound. Classification, if I do, so monohydric alcohol is also classified into the four types, that is allylic, alkylic, benzylic, and vinylic, right? And for the nomenclature, we all know this thing from our very beginning of 10th and 11th class, that is for alcohol, we use a suffix called "ol", right? So ROH is named as alkanol. For example, methanol, butanol, pentanol, all these things. And how will you prepare alcohol? That is from alkenes, from carbonyl compounds, from Grignard reagent. So we all cover this thing. ठीक है? So सबको clear है mind map about alcohol? Anyone having doubt related to this mind map? Anyone having any kind of doubt related to this mind map? No? Good. So let's see quickly the mind map of phenol as well, right? So फटाफट mind map देख लेते हैं phenol का भी, कि ये phenol का mind map क्या है भाई, क्या पूछ रहा है तुमसे. So if I'm talking about the mind map for the phenol, similarly physical boiling point is higher due to presence of the intramolecular hydrogen bonding, solubility. So due to the hydrogen bonding, they also are soluble. Chemical properties, just we discussed in today class, that is the chemical properties. They undergo electrophilic substitution reaction, Colby's reaction, RTM reaction, coupling reaction, right? And used for the household product, right? This phenol is also used as a disinfectant, right? This phenol is used as a disinfectant also. So for the home cleaning purpose, industrial synthesis, all we are using this phenol. And the classification of phenol is also on the basis of number of OH group attached. If only one OH group is attached, then it is known as monohydric. If the two, then it is known as a dihydric. If more than two, or we say three OH group is attached, then it is known as a trihydric. Right? So for monohydric, name is phenol. Similarly for the dihydric and the trihydric. Now for preparation. So from the haloarenes, we prepare phenol by the use of very, very important reactions. From benzene sulfonic acid, from disonium salt, and from cumene. Please repeat preparation in short, right? Yes, beta, you're talking about the preparation of phenol. Preparation of phenol, you are talking about the. Okay. Yes, sir. Okay. So basically, preparation of phenol now from the haloarene. How will you prepare from the haloarene, beta? We know that through the DOS process, right? We know now whenever the chlorobenzene is treated with NaOH in presence of 623 Kelvin, then what will form? They will form nothing but sodium phenoxide, which on hydrolysis, right? Which one? Acidic hydrolysis, that is with HCl, they will give phenol. So this is the first method, right? From halogenanes. So from halogenanes, by the DOS process, you prepare this thing. Similarly, from the benzene sulfonic acid means what, beta? Benzene sulfonic acid means that is SO3Na. So when you treat with SO3Na with the NaOH, what will form? Na2SO3 and phenol will be formed, right? From the disonium salt, BDC. So we know that from BDC as well, from BDC means what, beta? N2Cl. So when you treat N2Cl with the warm water only, right, then also we get the phenol. So this all method we already discussed this thing in detail, right? And from cumene also we prepare phenol. समझ आ गया कैसे कैसे हम लोगों ने prepare किया है? We already discussed this thing in a detailed way, right? So here I'm just giving a idea दिया मैंने कि कैसे बनाया है हम लोगों ने, ठीक है? So this is the preparation of the phenol from all this thing. Now these are the question. So I'm going to discuss two question and rest of the question is homework for all of you, right? So this is the first question, that is the match the reagent of list 1 with the list 2 obtained from phenol. सबको बताना है बेटा. This thing we already discussed और ये तुम लोग का जेई नीट में आया भी ये क्वेश्चन, तो फटाफट जल्दी से बताओगे. First of all, benzoquinol. We already discussed thing na benzoquinol. What is this benzoquinol? Oxidation. What? Sodium dichromate. So can anyone tell me the first benzoquinol? What is the suitable option? A, B, C, D. Yeah, that is D. Very good, very good, very good. Right? Yeah, good beta. So this benzoquinol is this. So this is the first. Now zinc dust. So obtained from phenol. So we have a phenol, right? So when we treat phenol with the zinc, then what will happen, beta? ZNO, right? So what will form? That is benzene only. This, whenever the phenol is treated with the zinc, so what they form? ZNO will be removed, so only benzene will be formed. So zinc dust, benzene. So this is the second. And the rest is NaOH plus CHCl3. So in which case we are getting salicylaldehyde and salicylic acid. So basically in NaOH and CO2H plus we'll get salicylic acid. So this is the fourth one and this is the third one, right? This is known as chloroform, right? Yes, I get the couple of answer, right? Very good, Peter. So which one is the correct option? That is first having D. So first D, yeah. So only option D is the correct, right? So A having fourth option, B having 3 option, C having the second and D having the first option. So सबने सही बोला है, very good. तुम लोगों ने इसका मतलब बहुत अच्छे से सुना है. That's why तुम सबने अच्छा response किया इसका. Very good बेटा, right? Now move to the next question. Given below are the two statements. The acidic strength of the monosubstituted nitrophenol is higher than phenol because of electron withdrawing nitro group. And the statement 2 is orthonitrophenol, metanitrophenol and paranitrophenol we have the same acidic strength as they have the one nitro group attached to the phenolic ring. So jaldi batao whether both the statement is true or yeah, I got the couple of answer. किसी ने सी बोला है, very good. C. Yes, very good. Good. Very good. So सभी बच्चों ने ऑलमोस्ट क्या बोला है बेटा? सी आंसर्स को बोला है, राइट? दैट इज स्टेटमेंट 1 तो करेक्ट है, लेकिन व्हाट अबाउट द स्टेटमेंट 2? सो स्टेटमेंट 2 बोल रहे हैं बच्चे कि अबाउट द स्टेटमेंट 2 इज इनकरेक्ट. Good. So why statement 2 is incorrect? Can anyone explain me? Why statement 2 is incorrect? Yes? Very good. यानी C option बिल्कुल ही सही है. That is statement 1 is correct because acidic strength of monosubstituted nitrophenol is more because this is electron withdrawing group, right? Now this is also yes electron density only at ortho and para position. Very good beta, right? So सबने ही सही आंसर्स किया है. So ठीक है, सबने सही किया. Very good. So what is the homework for your tomorrow class, right? So just revise all this thing, revise all this important thing. That is alcohol, phenol and ether. In tomorrow class we are going to discuss in the ether part because ether is very small portion, so we cover ether in a 20-25 minutes, and rest of the time we are going to solve a question related to this one, right? So we are going to do question. C option, right? That is Lucas region, right? Very good. So या वेरी गुड. तो सभी बहुत सही आंसर्स कर रहे हो आप लोग, सबने ही रीड किया है. तो जस्ट इसको एक बार और रिवाइज कर लेना. जस्ट रिवाइज वंस अगेन, एंड इन टुमारो क्लास वी आर गोइंग टू सॉल्व questions only, right? After finishing ether part, we are going to solve the questions only in the tomorrow part, right? So till take care and enjoy your studies, right? Good. Yes. Take care, all of you.